We have traveled from the sun's searing core to the icy outcrops of the Kuiper belt, but the solar system does not end at Pluto. It extends another 1,000 times farther, into a ghostly sphere of frozen bodies so distant that a comet takes millions of years to complete one lap. This is the Oort cloud, the sun's final outpost, where the nearest star is only a couple of times farther than the opposite edge of our own system. Our comet cloud very nearly brushes theirs. Think about that. Somewhere out there, the sun's gravitational pull becomes weaker than the pull of passing stars. That boundary is the sun's Hill sphere. And inside that boundary, frozen trillions of objects orbit so slowly and so far away that we have never seen them directly. So how do we know they exist? Because every few decades, a speck of light arrives from the deep, screaming past the inner planets at tens of kilometers per second. A comet. And that comet carries the Oort cloud's fingerprint. Imagine an enormous faint bubble. Inside it, trillions of icy fragments, comets waiting to be born. They are leftovers from the birth of the solar system, flung out by the gravity of the giant planets billions of years ago. Now they orbit in slow motion, their speeds less than a fraction of a kilometer per second. The total mass of all that material, roughly 5 Earths, packed into a volume that dwarfs everything else in the solar system combined. Meet Halley's comet, and meet the comparison that shows you how far out the Oort cloud really is. Halley returns every 75 years, and its aphelion is only 35 astronomical units, still inside the Kuiper belt. By its orbit, it is a short-period comet, though it was almost certainly an Oort cloud native that Jupiter long ago captured into that tight loop. Truly long-period comets come from much deeper. Some swing out tens of thousands of astronomical units, taking 1,000,000 years for a single lap. Hale-Bopp at 370 astronomical units and 2,500 years is only a mid-range example. That gap between Halley's 35 and the Oort cloud's 100,000 is the gap between the belt you know and the shell you are about to meet. Here is the scale, and it is impossible to grasp linearly, so we use a logarithmic ladder. Each step multiplies the distance by 10. Earth sits at 1 astronomical unit, Pluto 39. The inner edge of the Oort cloud is at roughly 2,000 astronomical units, 30 times farther out than Eris and twice as far as Sedna's most distant point. And the outer edge, 100,000 astronomical units, that is 1,000 times farther than Pluto. To get there from here, you would have to cross the entire Kuiper belt, the scattered disk, and then a void 200 times wider than the space between the Sun and Neptune. By 100,000 astronomical units, that is the Sun's Hill sphere. Inside that radius, the Sun's gravity is the dominant force. Outside, the gravitational pull of passing stars and the galactic center can tear objects away. So the Oort cloud's outer edge is not a sharp wall, it is a fuzzy boundary where the Sun loses its grip. Beyond lies interstellar space, where objects like Oumuamua drift, born around other stars. The Oort cloud is the envelope of our system, the last address in the solar system's postal code. Now watch the zoom. We start at the Sun, a bright dot. The inner planets flash by. Jupiter, Saturn, Uranus, Neptune. Then the Kuiper belt, a thin ring of specks. Keep pulling back. The dots vanish. Nothing but darkness for a long, long time. Then a faint glow. The inner Oort cloud, a shell of icy grains. Keep pulling back. The shell thickens, becomes a hazy sphere. Farther still, the outer Oort cloud, faint as a phantom. At the edge, the zoom stops. That faint sphere is 100,000 astronomical units across. Beyond it, the nearest star is Proxima Centauri at 275,000 astronomical units. The Oort cloud is the bubble we live in, the Sun's domain, frozen and deep. Put numbers on it. The Kuiper belt's outer edge is about 50 astronomical units. The inner Oort cloud begins at 2,040 times farther. The outer Oort cloud at 100,000 astronomical units, 2,000 times farther than the Kuiper belt edge. That is not a larger ring. That is an entirely different scale of emptiness, and yet every long-period comet we see comes from that vast reservoir. Here is a quick check. The Oort cloud's total mass, spread across trillions of icy bodies, is roughly how much? Equivalent to 5 Earths, 50 Earths, half an Earth, or 500 Earths. Pause the video and commit to an answer. The answer is about 5 Earths. Option A. That might seem small for such an enormous volume, but remember, These are tiny comet nuclei, each typically a kilometer or less across. The total mass is surprisingly modest, and that tells us the Oort cloud is mostly empty space, a ghostly shell holding the deep memory of planet formation. 3 things are yours now. First, the Oort cloud is real, a vast, spherical shell of frozen debris, holding maybe 5 Earths' worth of material in a volume so large it dwarfs everything else. Second, its outer edge marks the Sun's Hill sphere, the distance where the Sun's gravity yields to the stars. Beyond that, the solar system dissolves into interstellar space. Third, every long-period comet, from Hale, Bop to the next one that appears unannounced, is a piece of the Oort cloud falling toward us, carrying pristine material from the dawn of the solar system. Next lecture, we will meet comets close up, their nuclei, their tails, and the missions that have touched them.